electricity is then transmitted through power lines to humans and business. Okay, so hydroelectric energy, also called hydroelectricity power. How does electricity energy work? We also know that hydroelectric power plants have a reservoir of water, a gate or valve to control how much water flow out of the reservoir, and an outlet or place where the water ends up after flowing downward. Water gains potential energy just before it spills over the top of a dam or flow down a hill. The potential energy is converted into kinetic energy as water flow downhill. The water can be used to turn the blades of a turbine to generate electricity, which is distributed to the power plant's customers. There are three types of hydropower system. Okay, so number one is embouldment, number two run of river, and number three pumped storage. We discuss all three types one by one. Okay, so first type is impoundment. Most of the large hydropower system are impoundment type. A dam is used to store river water in a reservoir. Water released from the reservoir flow through a turbine to generate electricity. The water may be released either to meet changing electricity needs or to maintain a constant reservoir level. This is a diagram. This is a diagram of impoundment. With the help of this diagram, we understand the working process of impoundment. Okay. So in this diagram, first we see this is a reservoir. Okay. You can see this is a reservoir. Reservoir, a dam is constructed across a river, creating a large reservoir of water. The dam collect and store the potential energy of the water held back by the dam. So next is this is a intake. Okay, this is a intake. Water flow from the reservoir through a narrow passage called the intake. A screen may be used to filter. After the intake, the water pass out into this intake and then reach a penstock. The intake lead to a large pipe called the penstock. The penstock channel the water down from the reservoir towards the power plant, which is usually located downstream from the dam. The penstock is angled downward to screen to increase the water velocity as it travels through the pipe. This increase in velocity increases the kinetic energy of the water. And then next is this is a turbine. The penstock lead to the turbine. The high pressure water exciting the penstock strike the blades of the turbine. Then the blades of the turbine spin. The turbine convert the kinetic energy of the moving water into the mechanical energy. After the turbine, the next step is generator. The turbine shaft is connected to the shaft of a generator. As the turbine shaft spins, it spins the shaft of the generator, which converts the mechanical energy from the turbine into the electrical energy. When mechanical energy converts into electrical energy, then the next step is powerhouse. Okay, you can see this is a powerhouse. The generator and other electrical equipment are housed in a building called the powerhouse. After the power Hello, can you hear my voice clearly?
Yes, ma'am.
I apologize my poor internet connection. So I repeat this diagram again. Okay. So in with the help of this diagram, we understand the working process of embodiment. We understand how we can generate electricity with the help of embodiment. Okay, so first we see this is a reservoir. Okay, a dam is constructed across a river, creating a large reservoir of water. The dam collect and store the potential energy of the water held back by dam. And next we see intake. Intake water flow from the reservoir through a narrow passage called the intake. And next we see the pinstock. The pinstock lead to the large pipe called the pinstock. The pinstock channels the water down from the reservoir towards the power plant, which is usually located downstream from the dam. The pinstock is angled downward to increase the water velocity as it travels through the pipe. This increase in velocity increase the kinetic energy of the water. Okay, so after the pinstock, the next step is the turbine. The pinstock lead to the turbine. The high pressure water exciting the pinstock strikes the blades of the water, causing the turbine to spin. The turbine converts the kinetic energy of the moving water into the mechanical energy. Okay, so after the turbine, the next is generator. We see the turbine shaft is connected to the shaft of a generator. A turbine shaft it spins the shaft of the generator, which converts the mechanical energy from the turbine into electrical energy. After the generator, the next is powerhouse. The generator and other electrical equipment are housed in a building called the powerhouse. And next and last is transmission lines. The transmission lines work the electricity generated by the power plant is carried over long distance transmission line to homes and businesses. Okay, so this diagram had to understand the working process of inboundment. In this diagram, we see that we store the water at potential energy, then the potential energy convert into kinetic energy, and when water strike the turbine at high pressure, then the turbine shaft rotate and attach the generator, work convert the mechanical energy into electrical energy. Okay, so then last is with the help of transmission lines, we use electricity for our homes, businesses, and other purposes. So this is the diagram understand working process of embodiment. Okay, so two types of embodiment: dam, number one, and number two, spillway. Okay, what is dam and its construction? Basically, dams store the energy in the form of potential energy. When water flows down from the reservoir into the turbine, this potential energy is converted to kinetic energy that rotates the turbine blades. The type of dam to be built and its construction method depends on various factors. Okay, for example, water height of the reservoir, the shape and size of the valley at the purpose construction site has these will determine the capacity of the hydropower plant, and also geology of the valley walls and floor. This will determine the construction material and associated cost. We also divided dams into two types: embankment dams and concrete dams. Okay, so this is the diagram of embankment dams. We understand this diagram, we understand embankment dam process with the help of these diagrams. Okay, we can see, okay, numbers show in these diagrams. Okay, so we understand these numbers one by one, and what is working process of these numbers and them, and how with the help of this dam we generate the electricity. So first number is rock fill. Okay, the bulk of the dam is made of rock fill. This section is the largest and the most upstream component of the dam. Rockfill is used because it is firm and inexpensive. The maximum size of the rocks in this section is 1000 millimeters. Okay. And the second number is impervious core. Located downstream from the rock fill in the impervious core, this section is made of sandy. The impervious core is less permeable than the rock fill, which help to prevent water from seeping through the dam. And number three is coarse and fine filters. Downstream from the downstream from the impervious core is a layer of coarse filter followed by a layer of fine filters. These filters act as a drainage layer, allowing water the seeps through the rock fill to drain out of the dam, preventing a build-up of pressure. The filter layers are typically made of gravel and sand with the porous material close to the rock fill. And the point four is transition zone. Transition zone downstream from the fine filters in the transition zone. This zone is made of material with a grain size of up to 150 millimeters. The transition zone acts as a buffer between the fine filters. The point five is reprep. Okay, the reprep, the downstream face of the dam is protected by the rear of reprep. Reprep is typically made of large angular rocks. It protects the dam from erosion by waves and currents. And point six is foundation. The foundation of the dam consists of two layers. Okay, number one layer is weathered rock and fresh rock. The dam is built on foundation of solid rock to ensure stability. The weathered rock is the top layer of bedrock, which may be more broken into fresh rock. So this diagram of embankment dams, we see all types of embankment dams. And next is concrete dams. As the name suggests, concrete is used to construct the dam. Several construction methods of concrete dam are purpose concrete gravity dam, ruler compacted concrete dam, and concrete arch dam. Basically, the weight of concrete or the shape of the dam hold back the water. Concrete is a expensive material and the construction methods vary. Some dams use concrete while others use limestone concrete. Can you hear my voice? Okay, so we see that spillways. A spillway is a channel or structure built beside or part of a dam, designed to allow controlled release of excess water. Spillway are safety as they prevent dam failure, which could result in flooding downstream. There are two main types of spillway: controlled and uncontrolled. Controlled spillway have gates or other mechanisms that allow engineers to regulate the amount of water flowing through the spillway. Uncontrolled spillways, sometimes called emergency spillways, are designed to automatically spill water once the reservoir reaches a certain level. For example, often controlled spillway, the Howell Dam spillway are a good example of controlled spillways. They are located on either side of the dam and each have multiple concrete gates. So, when dams are designed, provision must be made to cope with large floods. Spill are a pathway for flow the water to flow over the around the dam so that the dam itself is not breached. Spillways on concrete dam are usually constructed to allow water to flow over the top. Spillway in embankment dam are built at the side of the dam and away from the downstream face. If the water is allowed to flow over the dam, serious damage can occur to rocks or the earth that are used to construct it. Runoff river. Okay, what is runoff river? Runoff river plants drive energy from a water flow with minimum disruption of the flow or the surrounding. Runoff river hydroelectric plants use the power in the river water as it passes through the plant without causing an appreciable change in the river flow. Such systems are built on small dams that impound little water. Several systems have been designed without a reservoir or a dam. Okay, so in this video, with the help of this video, we understand the working process. One second. With the help of this video, we understand the working process of runoff river. Okay, producing electrical energy with the power of water is a wonderful, brilliant invention. The electrical current is often produced by water power. Current is often produced by water power station in the case of runoff river. Station in the case of runoff river hydroelectric power plants, the energy of the river itself is used for this type of power station. Power station create a kind of small water storage is often referred to as a bondage. The bigger the height difference between one side of wire and the other side, the higher the energy stored. This is also known as gravitational potential energy. The potential energy gap the stored water passes through an underground pipe. We see inlet pipe and outlet pipe system. A turbine usually of Kaplan turbine we use in this process. Okay, so water strike into the Kaplan turbine and the shaft of the turbine rotates and the generator connected to the turbine and then generate the electricity. Okay, so this is a transformer powerhouse, Kaplan dam, turbine. Okay, in this video, we understand the working process of run-of-river. So next is pumped storage. Pump storage hydropower system are operated different from conventional hydroelectric system. This system use falling water to generate power in the same manner as a conventional hydroelectric system. Water after falling through the turbine is collected in a reservoir. The irreversible turbine they work in both direction is used as the pump storage facility. When demand for electricity is low, the turbine is operated in the reversible mode to pump the water back to an upper reservoir. Water from the upper reservoir is released to generate power during periods of peak demand. By pumping water back to the upper reservoir using excess peak level electricity, we also generate. Okay, in this diagram, we understand the working process of pump storage. With the help of pump storage, how we can produce the electricity. Okay, so first is a low reservoir. Okay, the low reservoir, the lower reservoir collect and store water. Okay, or this is the intake. Water flow from the low reservoir to an intake structure to pump turbines. And next, this section is a turbine. When operating in pumping mode of the electric motors power the pump turbines which pump water uphill to the upper reservoir. And then electricity source, the electricity to power the pump turbines can come from the variety of sources including the power grid in nuclear power plants or solar power plants. This is the parts of used for constructions of pump storage. Now we understand how we can generate the electricity with the help of pump storage. The upper reservoir stores water at a higher elevation. The higher the elevation, the greater the potential energy of the water. When the demand for electricity is high, water flow from the upper reservoir through a penstock. The penstock channels the water down from the reservoir towards the power plant, which is usually located downstream. The penstock is angled downstream to increase the water velocity as it travels through the pipe. This increase in velocity increases the kinetic energy of the water. The high pressure water exciting the penstock strike the blades of the turbine, causing the turbine to spin. The turbine convert the kinetic energy of the moving water into the mechanical energy. Okay, the turbine shaft is connected to the shaft of the generator. As the turbine shaft spins the shaft of the generator, which convert the mechanical energy from the turbine into electrical energy. The generator and other electrical equipment are housed in a building called the powerhouse. The electricity generated by the powerhouse in carry over a long distance transmission lines. So this diagram of pump storage, and we understand the working process of pump storage. Okay, so next is what is benefits of pump storage. There are many benefits of pump storage. For example, we use pump storage, improve energy regulation and operation of the power grid, such as standby and reservoir duties, black station start frequency control, and flexible reactive building. We also use creates environmental benefits such as reduce gaseous emissions. This is a very important and has little environment impact during its operation, and allow flexible and revolving commercial operation across a variety of electrical power supply scenarios. Okay, so next is what is the advantages of hydropower and disadvantages of hydropower. First, we discuss advantages. Hydropower on the natural flow of water, making it a renewable energy source as long as there is rain for rivers and streams. Hydropower can be generated continuously. Once a hydropower plant is built, its operational costs are relatively low compared to other forms of energy generation. This is because water, the fuel of hydropower, is free and abundant. Hydropower plants produce minimum greenhouse gas emissions during operation, making them cleaner than fossil fuel-based power plants. This help in mitigating climate change and reducing air pollution. And hydropower generation can be easily forecasted based on water flow patterns, uh, making a source of energy. Hydropower reservoirs can serve multiple purposes such as flow control, etc. And now we discuss disadvantages of hydropower. The construction of hydropower dam or reservoir can be significant impacts, including habitat destructions. Large-scale hydropower projects often require substantial land areas and uh, very dangerous. Not all regions have suitable technology, water resources for hydropower development. This is a limit. The upfront capital cost associated with building hydropower plants, exceptionally large dams, can be considered. Okay, so this is advantages and disadvantages of hydropower. Okay, this topic of hydropower is covered. Any question in this topic? Any question in this topic? Any question? Any question in
Ma'am,
this topic?
I ask one question.
Okay, what?
Why is hydropower a renewable source of energy?
Okay. Hydropower is considered a renewable source of energy because it on the natural water cycle, which continuously replenish the water used to generate electricity. When water flow through the hydropower plant, it turns turbine connected to generate, producing electricity. Unlike fossil fuels, which are finite and non-renewable, water is constant through participation, such as rainfall and snow. Snow melt has long as there is rainfall and water. Runoff hydropower plants can continue to generate electricity without depleting the resource. Therefore, hydropower is sustainable over a long term and does not contribute to the depletion of finite resources or environmental harm associated with non-renewable energy sources. Okay,
Thank you, ma'am.
okay, welcome. So now we start. The next topic is geothermal energy. In this topic, we will understand geothermal energy because we know that this is a renewable energy resource that taps into Earth internal heat. So first, what is geothermal energy? Geothermal energy is the Earth heightened heat source, a result of the temperatures in our planet almost 6,000 Celsius. This heat naturally travel upward, warming rocks and fluids underground. In some areas, specific geological conditions like volcanic activity trap this heat in underground pockets called geothermal reservoirs. These reservoirs contain hot water or steam, a valuable resource we can use for various applications. This is a diagram of geothermal. With the help of this diagram, we understand the structure of geothermal energy. In this diagram, we see that the interior of the Earth or Earth core is extremely hot with a temperature of about 4,200 Celsius. Some of heat is formation of Earth some 4.5 billion year ago. The decay of radioactive material in the core is the source of the heat. The interior consists of two layers. The inner layer is a solid iron core. This is surrounded by the molten rock called magma. The heat from this hot inner core flow to the cooler outer crust of the earth. It is not possible to capture this vast amount of heat. Several natural geologic processes allow for some of this heat to be concentrated at temperatures and depth for commercial labor. The energy from this heat source is called the geothermal energy source, which is being captured and used in various applications. The outer core, okay, this is outer core. Now we discuss inner core. Now this is outer core. The outer core or the magma is surrounded by the mantle approximate 2,897 kilometer thick. It is made of magma and rocks. The outermost layer of the earth is called crust. It is 3 to 5 miles thick under the ocean and 50 to 35 miles thick in the continents. The earth crust is made of pieces of land and oceans called plates. Magma is extended to the Earth's surface near the edges of these plates, where organic activities occur. The physical and chemical characteristics of the Earth's inner core, large bodies of water and trapped in the pores of the underground rocks and heated by the earth heat. The temperature of the rocks and the water get hotter, progressing towards the inner core. The use of heat from this energy source can be used to heat buildings or generate electricity. Geothermal energy is considered a renewable energy because water by rainfall and the heat is continuously produced inside the earth. Okay, so next is how geothermal energy works. um, we know that geothermal power plants function by drilling wells deep into the earth to reach geothermal reservoirs containing hot water or steam. This steam or hot water spins a turbine connected to the generator, producing electricity. The cool water or steam is re-injected back underground, making it a sustainable process. Okay, so with the help of this diagram, we understand how geothermal energy works. So first we see that permeable cap rocks. Okay, this is a permeable cap rocks. This is a layer of rock that traps the hot water underground. It acts like a lid. Thermal conduction is a transfer of heat by direct contact in the diagram. The geothermal well and the hot spring or steam vent are losing heat to the surrounding rock and soil by thermal conduction. Conduction mean the molecules vibrate, okay, not move one place to another place. And next we see that this is a reservoir, mean thermal convection, okay. This is a layer of rock that contains the hot water. The thermal convection is the transfer of heat by the movement of fluids. In the diagram, the hot fluids are moving around within the reservoir by thermal convection. Okay, so next we see this is a hot fluid. This is the hot water that is trapped in the reservoir. And next, after the hot fluids, geothermal well. Okay, you see, this is a geothermal well. This is a well that has been drilled down into the reservoir to tap into the hot water. The hot water can be used to generate electricity or for heating. After this hot spring or steam well. So this is hot spring or steam well. This is a natural opening in the earth crust that allow hot water or steam to escape to the surface. So, with the help of this diagram, we understand how geothermal energy works, and we also discuss this diagram step by step. Okay, so there are three types of geothermal power plants. Number one is dry steam plant, number two flash steam plant, and number three binary cycle plant. Okay, so we discuss three types one by one. Okay, so this is dry steam power plant. With the help of this diagram, we understand our we understand our parts include into the dry steam power plants and what is the working process of dry steam plants, and with the help of these power plants we can generate electricity. Okay, so first we see this is a production well. Okay, this is a production well. In this diagram, the process starts with underground steam or hot water reservoir. This heat source is labeled geothermal zone in the diagram. Well are drilled to tap into this reservoir, and steam or hot water is extracted from this well. After the production well, next is turbine. Okay, this is turbine. The extracted steam or hot water traveling upward to the well. Spin the turbine blades. The turbine converts the kinetic energy of the moving steam into rotational energy. After the turbine spins, the steam rises higher and generates electricity. Electricity is generated by turbine blades and ਉਹਨੇ ਮੈਨੂੰ ਖੁਦ ਬਿਠਾਇਆ ਕਿ ਮੈਨੂੰ ਪਤਾ ਚੱਲੇਗਾ ਇੰਟਰਨੈਟ I am really sorry. My internet from very poor. I don't know. Okay, so we start again this diagram. With the help of this diagram, we understand that drive steam power plants working process. Okay, so first we see steam production well. The process start with underground steam or hot water reservoir. This heat source is labeled geothermal zone in the diagram well. Well are drilled up to tap into this reservoir and steam or hot water is extracted from this well. So next, this is a turbine. The extracted steam or hot water traveling upwards to the well. Spin the turbine blade so the turbine convert the kinetic energy of the moving steam into rotational energy. So next, after the turbine, this is a generator. Okay, the rotating shaft of the turbine is connected to the generator. The generator convert the rotational energy from the turbine into electrical energy. Then this electrical energy into convert mechanical energy, and after the mechanical energy, we use into useful purposes. And this is a condenser. Condense extra heat, steam into the liquid form. After spinning the turbine, the steam loses thermal energy and condenses into water. The condenser uses cooling water to cool down the used steam. After the condenser, the next is cooling water. This is a cooling water. The diagram shows the cooling water entering from the bottom and exciting at the top. This water is used to condense the steam into the condenser. And after the cooling tower, the last is injection well. Okay. The condensed water, now cooler, is then injected back underground through an injection well. This well injects the water back into the geothermal reservoir to maintain pressure and keep the process going. So this is a working process of dry steam power plants. With we use dry steam power plants and generate the electricity. So next type is flash steam hydrothermal power plant. So first, what is flash steam? Flash steam power plant used to hydrothermal fluid, which is primarily water for electricity generation. Water is available at temperature above 200 Celsius and at a high pressure. We see basic arrangement of this system with diagram. Okay, with the help of this diagram, we understand the working process of flash steam hydrothermal power plants. Okay, so first is the geothermal zone. Okay, you can see this is a geothermal zone. This is the heat source located underground. Hot water or steam resides in pockets with the rocks. And then next is production well. This is a production well, a well drill into a geothermal zone to extract hot water to steam. And after this, this is the injection well drilled to return the cold water back underground. And this is a brine, the hot water or steam from the geothermal zone, which may be also contain dissolved minerals. The steam, the vapor produced from the brine after flashes to lower pressure due to the lower elevation separated by the splatter. We see these diagrams and also again turbine. Um, a machine that converts the kinetic energy of the moving steam into rotational energy. Then turbine, and next is generator. Same we discussed before. Generator machine that converts the rotational energy from the turbine into electrical energy, and the condenser, heat exchanger that cools and condenses the source steam from the turbine into water. And next is cooling water. Water circulates through the condenser to absorb heat from the exhaust stream. And next is this is a air and water vapor, the maximum of air and water vapor released from the cooling tower after the cooling water is used in the condenser. And last is waste brine. This is waste brine, the water left over after steam extraction. It is re-injected back into the geothermal zone, the injection well. Okay, so this is our parts include into the fresh steam hydrothermal power plants. Now we understand the working process of fresh hydrothermal power plants. Hot water or steam is extracted from the geothermal zone through the production. The hot water or steam travel to the turbine where it spins the blades, converted thermal energy into mechanical energy. The turbine is connected to the generator, which converts the mechanical energy from the turbine into electrical energy. After passing through the turbine, the low pressure steam travels to the condenser where it is cooled by circulating water. This process condenses the steam back into water. Okay, the hot the hot water from the condenser is pumped to the cooling tower where it releases heat into the atmosphere and is cooled down. The cooled down water is then returned to the condenser to repeat the cooling process. The remaining water carbonine is re-injected back underground through the injection well. So third type is binary cycle hydrothermal power plant. This is a diagram of binary cycle hydrothermal power plants. We understand the working process of binary cycle hydro power plants. Okay, so in this diagram, we see first is heat exchanger. This is a transfer heat from the geothermal brine to another liquid, typically isobutane at lower boiling points. And this is a production well. This is a well drilled into the ground to access the hot geothermal brine. And we see this is geothermal zone, the area underground that contains the geothermal brine. Okay, so next is injection well. This is an injection well. Well, the we injects the cool brine back underground. Okay, so this is a pump. This pump moves the geothermal brine from the production well to the heat exchanger, and this is a turbine. The turbine spins due to the high pressure steam from the isobutane, which converts the thermal energy from the brine into mechanical energy. Okay, so next is a generator. Generator convert the mechanical energy into electrical energy and also attached with the condenser. Condenses the use butane vapor back into the liquid state so it can be recycled. Okay, this is a cycle process. Last is cooling tower, water they cool down the condenser and it's spray back down. So this is with the help of this diagram we understand the uh, binary cycle hydrothermal power plant. Okay, so next is advantages of geothermal energy and these advantages of geothermal energy. First, we discuss the advantages. Okay, geothermal heat is constant replenished from earth core, produce minimum greenhouse gas emission compared to fossil fuels. Geothermal plants can operate 24 by 7 of weather conditions, provides a constant source of electricity for the grid. And now we discuss disadvantages. Geothermal energy does have limitations. Suitable geothermal resources are connected in specific regions near volcanic activity. Drilling and building geothermal plants requires a significant upfront investment. There are also the potential for environmental impact if wells are not constructed or managed, leading to ground subsidence or water contamination. So, what is application of geothermal energy? Uh, Electricity generation. The primary application of geothermal energy is generating clean and reliable electricity. Hot water from geothermal sources can be used direct for space heating in homes. Okay, so This is our geothermal energy topic is covered. Now covered. Okay, we will meet after 10 minutes break. Okay, now we start the next topic. Our next topic is biomass energy. What is biomass energy? People have used biomass energy, from living things, first made wood fired for cooking or keeping warm. Biomass is organic, meaning it is made of material that comes from living organisms, such as plants and animals. The most common biomass materials used for energy are plants, wood, and waste. These are called biomass feedstocks. Biomass energy can also be a non-renewable energy source. Biomass contain energy first derived from the sun. Plants absorb the sun energy through the photosynthesis and convert carbon dioxide and water into nutrients. Okay, the energy from these organisms can be transferred into the usable energy through direct and indirect means. Biomass can be burned to create heat converted into electricity, and then we use this electricity for different purposes. Okay, this is a cycle of biocycle. In this diagram, we see first, this is a combustion, okay? Organic material is burned to release heat. This heat can be used to generate electricity, or okay, and the trees, when sunrise strike to the tree, uh, the photosynthesis is started. Plants use sunlight, water, and carbon dioxide to produce carbohydrates. These carbohydrates store energy from the sun, and this is a biomass. This refers to organic matter used as an energy source, and decompositions. Organic material decompose, which breaks down complex organic molecule into simpler organic molecule. This process is fueled by microorganisms like bacteria and fungi. So this is a cycle of biomass. In this cycle, we see that photosynthesis is started when the sun, uh, when rays of sun strike to the tree, and biomass. We can also see biomass, organic material, combustions, and the carbon dioxide release. And these release carbon dioxide are also absorbed into forest or trees. Why we use biomass? Biomass can be also used to produce biofuels, which is short for biomass fuel. It can be in the form of both liquid and gas. Biopower refers to biomass power station that produce electricity. The major use of biofuel in the transportation sector. Okay, so mostly biofuel used in transportation sector. Okay, so thermal conversion. Biomass can be burned by thermal conversion and used for energy. Thermal conversion involves heating the biomass feedstock in order to burn dehydrates. The most familiar biomass feedstock for thermal conversion and raw materials. There are several types of thermal conversion. Number one, direct firing and cone firing. Number two, pyrolysis. Number three, gasification. Number four, anaerobic decomposition. Okay, so now we see that first we discuss first type. We see that this is a direct firing and co-firing. First, we study the direct firing. Biomass are burned directly in a furnace. This release heat energy. Heat produced from burning the brackets convert water into high pressure steam. The high pressure steam spin a turbine. The turbine rotation generate electricity. Connected generator. This electricity can be used for various purposes like powering buildings or manufacturing facilities. Okay. If we see this diagram, okay, so this is a burner, this is a turbine, and this is a generator, and this is a power station. Okay, power transmission lines. Or next is co-firing. Biomass is burned alongside a fossil fuel, typically coal in exciting coal power plants. This eliminates the need for constructing new facilities to process biomass. Co-firing reduce on coal, lower overall fossil fuel consumption. Biomass is a renewable resource, and burning it partially offset the greenhouse gas emission from burning coal. However, it's important to note that biomass combustion still release some greenhouse gases. For example, if we take an example and understand the co-firing process, we imagine a power plant that traditionally burn only coal for electricity generation. By adopting co-firing, the plant can introduce a portion of biomass briquettes along with the coal. This reduces the amount of coal burned, lower overall emissions, while some emission from biomass combustion remain. It's generally considered a cleaner alternative uh, on coal. Okay, this is an example of co-firing. Okay, so next type is pyrolysis. Pyrolysis is a a thermochemical process that breaks down organic material at high pressure, high temperature, around 200 Celsius to 300 Celsius, in the complete absence of oxygen. Okay, this lack of oxygen prevents combustion, burning, and instead triggers a chemical breakdown of a biomass. Okay, so if we take an example for understand the pyrolysis, imagine Taka, a farmer who wants to convert some of his crop waste into usable products. He cannot burn the waste directly because it might create air pollution. Pyrolysis offers a solution. Taka build a closed container called the pyrolysis chamber where he load the crop waste. He then heats the chamber to the required temperature without letting any oxygen in. Actually, uh, pyrolysis process occur in the absence of oxygen. Okay, in this process, we cannot use oxygen. Okay, this is a product of pyrolysis. First is pyrolysis oil. Okay, this dark liquid tall and can be burned for electricity generation. It's also a potential fuel source or component in other fuel or plastics. Next is sign gas. Okay, this sign gas mixture contain combustible components like hydrogen and carbon monoxides. It can be converted into various fuels such as sign natural gas or methane. The last is biochar. Okay, this charcoal like solid is rich in carbon and highly agricultural. So next type is gasification. Gasification is a thermochemical process that converts biomass into the combustible gas called syngas. If we understand the process of gasification, so imagine a large container called a gasifier. Okay, we can imagine a large container called a gasifier. Inside, okay, waste material like food, scraps, and some plastics are loaded as the feed is stored. Unlike burning, gasification happen at high temperature, maximum 700 Celsius, with the limited amount of oxygen. This control oxygen environment prevents complete combustion and triggers a breakdown of the material at a molecule level. uh, we take an example and understand the process of gasification. For example, we say a city, okay, collect a ton of municipal solid waste. Instead of sending it to a landfill, they transport it to a significant plant. The plant processes the waste in the gasifier, producing syngas. This syngas can be cleaned and burned in a turbine to generate electricity for thousands of homes. Proceeds further to create biofuels for transportation like ethanol or methanol. Use as a raw material for producing various chemicals and fertilizers. So last types is anaerobic decomposition. Anaerobic decomposition is a process where microorganisms, usually bacteria, break down material in the absence of oxygen. Anaerobic decomposition is an important process in landfills where biomass is break down and compressed, creating an aerobic environment. In the anaerobic environment, biomass decays and produces methane, which is a valuable energy source. This methane can replace fossil fuels. In addition to landfill and aerobic decomposition can also be uh, im- implemented and restore forms. Okay. So next is biomass and carbon cycle. We understand what is a biomass and carbon cycle. In this diagram, we say why biomass is considered as a renewable energy source because the first impression is that it's just another fuel type causing environment emission. During the combustion process, the fuel is burned and cannot be covered. So why is biomass in the same group with wind, solar, of hydropower? Because biomass is a renewable energy source because carbon dioxide burn during the combustion process release oxygen and fossil fuels because carbon dioxide burn during the combustion. Okay, so advantages and disadvantages of biomass. So biomass is a renewable energy source because renewable energy source that can be replenished through the sustainable practice. Biomass sorry, one second. Biomass is a renewable energy source that can be replenished through sustainable practice. Biomass can offset carbon emissions. Biomass energy can be stored and used when needed, unlike some renewable sources like solar or wind. Biomass production can compete with food production for land use. This is a disadvantage is processing biomass often on fossil fuel, reducing its overall sustainability. Biomass transportation can be inefficient due to its lower energy density compared to fossil solutions. So our last topic is cover, and this is our question section. Would for energy always better than using fossil fuels like coal or gas? Can anyone give me answer this question? Okay, I can again repeat. My question is, burning wood for energy always better than using fossil fuels like coal or gas? Can anyone give me answer this question, please?
Okay, ma'am. May I answer this question?
Okay. What's your name first?
Zohra.
Okay, Dora, you can answer this question.
Yes.
Okay.
Not always, because burning wood can be a good choice, but only if it's done. Sustainability. Imagine you are cutting down trees for firewood. If you plant new trees to replace the ones you cut, that's good. The new trees will eventually absorb the carbon dioxide released when you burn the old ones. This keeps things balanced. However, if you just keep cutting trees without planting new ones, that's a problem. The carbon released from burning the wood is not being respond as quickly,
Okay.
which can
Good.
contribute to climate change.
Okay, good, Zora. Any question more?
No, ma'am.
Okay, so our session is end.